Okay, here, so we're going to touch on a topic that we've seen before, which is how to integrate a logarithm, and then this leads quite nicely into some of those differentiate and hence problems for you to have a go at. So firstly, part A is asking us to differentiate x log to base e of x using the product rule. So if we've got y equals x, I'll use ln x instead, just easier to write. Using the product, we've got u equals x, so therefore u dash is 1. We've got that v is equal to ln x, so v dash is 1 on x. And therefore, dy on dx is equal to, so u dash v, so 1 times ln x, which is ln x, plus v dash times u, so 1x times x is just 1. So there's our derivative. Now, why this is important, and I suppose a bit of a hint, what this means is, well, therefore, the integral of ln x plus 1 dx must be equal to x ln x. And we're going to use that then in part B, because part B show by differentiation that the x log e of x minus x is a primitive of log e of x. So what that means is if we differentiate, so if we've got y equals x log, sorry, we're using ln x, so we'll go back to using ln x, x ln x minus x, then dy on dx is equal to, well, x ln x we just differentiated before, that's ln x plus 1, and then the differential of minus x is minus 1, and we can see that if we simplify that, we end up with ln x. Now, why that's important is we're saying that, well, if we differentiate this, we end up with ln x. So therefore, if we were to integrate ln x with respect to x, we would end up with the original expression that we started with, which is x ln x minus x. I suppose plus c, because there's no limits yet. Now, leading into part C then asks us to use this result to evaluate the integral between 1 and e of ln x. So we're asked to evaluate the integral between 1 and e of ln x dx. Well, from part B, we know that that is equal to x ln x minus x between e and 1, and we can say that that's from part B, so we don't need to show all our working out again. Now, that is equal to e ln e minus e minus 1 ln 1 minus 1. Okay, so a few exact values here. Excuse me, is that working this through here, we end up with ln e, which is e minus e minus ln 1, which is 0, minus 1, which is plus 1, and we end up with just 1. So therefore, the integral between 1 and e is of ln x dx is just 1. Now, why that question leads quite nicely into the differentiate and hence ones is because these are asking you to differentiate and then use your results to then integrate, similar to what we've just done here, that we've differentiated and then asked to use our result moving forward to find the integral of something. So you should be able to have a go at those problems now.